Hello everyone, welcome back. And today we are going to solve a weekly contest 488. And today, I would rate this contest as easy because all the problems are the standard problems or are the little variations of some of the problems. If you have solved a good number of questions or you are following some sheets, or even if you are preparing for interview or internship or placements, then it is like not that much difficult for you to actually solve the problem, right? So without wasting any time, let's get started and let's understand how to actually approach. If you are not able to solve, don't worry, I'm here to help you. So let's get started. The first question is, this is the easy as usual. Count dominant indices. So you are given an integer array nums of length n. An element at index is called dominant if num size is greater than the average of okay. Your task is to count the number of indices that are dominant. The average of, we already know that what is the average, and the rightmost element of the array is not in dominant. So problem is quite easy. We just have to do what the problem is saying to us. What they are saying actually is right. Let's say if this is an array, if this is an array, right? So we just have to count the number of dominant elements, right? And what it if nums of I is greater than the average of rest of the element. So this is what we have to actually, this is what we have to actually achieve. So for every index we just have to check for the rest of the elements if their average is less than our current element. If it is, then we simply count. So this is quite easy. We just have to do what the problem statement is saying to us. Let's see what the code is look like. I just calculated the sum so that I don't need to run a loop again and again from I plus 1 to the n, right? So I just did a pre-computation. You can also do it by your own, by what you can do, you can just simply pick one element and then for the rest of the element you just simply run a loop from I plus 1 to the rest of the element, calculate their average and then calculate. But what I'm doing over here is I'm just iterating over the array. I'm excluding my current element such that it is not be part of my answer, and after that I'm just calculating the answer of the rest of the elements, average of the rest of the elements. If it is verify or validate the condition, that I'm simply incrementing the count variable and just returning the count. It is quite easy problem, nothing too fancy, nothing too complicated. So you can easily solve it. Just understand what is the problem is saying. Just make sure to read the problem statement clearly. That will give you an idea that okay, what the problem is and how to actually approach it, right? Because sometimes what happens is you read a problem statement in a different manner, so and you are actually working on different approach, so that's conflict and you are not able to solve, right? So make sure to understand the problem correctly. Let's move to the second problem. If you're talking about the time complexity is so often, so nothing fancy. So let's move to the second problem. This is pretty easy. This is pretty easy. I'm not saying it because I solved it, but it is easy because it's a standard problem. Let's understand what this problem is and why I'm saying it's a standard problem, right? So you are given an integer array nums. You repeatedly apply the following merge operation until no changes can be made. If any two adjacent elements are equal, choose the leftmost such adjacent pair in the current array and replace them with a single element equal to their sum, right? After each merge operation, the array size decreases by 1. Repeat the operation on the updated array until no more changes can be made. Return the final array after all operation perform. Okay, quite easy. Let's see the example, what the problem is saying. What we have to do, we have an array, right? This is our array, and we have to do if there is a two adjacent element, equal, then we just have to just do their summation and then put back to the inside the array. For example, if you see where it is 1 and 1 are the sum, so my new arrays look like 3 2 2, right? So this is my new array, but as this told that we have to perform this operation repeatedly. So if you see, my current array become this, but when I reach to 2, then the previous element is also equal to 2. Then we simply remove both of them and put their summation. So this is my updated array. So this is what I have to return. Pretty easy, pretty simple question. If you see, this is the output. If you see their example as well, that two elements are equal to the merge, like 1 plus 1 is equal, then we did a merge. Now array become like this. last two elements are equal, then we did this, and then array become like this. Then no adjacent element is equal, then we simply return as our updated array, right? So this is the question. How to actually approach? Let's see. Our problem is, this is the question, right? And we just have to perform the operation for the adjacent element. So make sure whenever you have to perform such operation, right, what you are doing it, you are just making sure of comparison with two elements, two consecutive elements, right? Either it would be your, right now we are dealing with numbers, either it would be with characters, strings, right? So make sure whenever you have such problems, like make sure to think about some sort of data structure which you can use, which actually help you to perform this operation in a much better complexity. Let's say if you want, like, if what you would do as a brute force approach, what you can do, you just simply run a loop. Like instead of writing a pseudocode, I just explain you over here. So from 3 you go to 1, right? And after that you check after 1 is there is an equal element. If it is, then you're just summation of both of them and creating a new array, then putting that element inside your new array, then again repeating that process, right? So instead of doing that, you should think of some data structure which actually gives you the operation in a much lesser amount of time. So what we can do, let's just process, right? So let's, my current element is 3, right? So I'll just write it down 3. Then I got another element which is 1, so I write it down. When I move further, I got 1. So don't you think, if I know what the previous element is and what are the previous element, then it become really easy for me to actually find out what are the equal elements and then simply sum them, right? So one is brute force, where you just run a loop from I minus 1 to the rest of the element. If it is, then calculate their sum, and after that just need to create a new array and then store it. And one another approach which we can use it, why not we can just simply use a stack data structure? Because if you see at this stage, what my top element is 1. Now when I got 1, I just simply compare with the top element of stack. If both are equal, then I just remove both of them and then put their summation. Now I move to 2, right? So now second last two elements are equal. My current element say it is 2, but and the stack top element is 2. If I compare, then both are equal, then simply remove and then do a summation. So don't you think it is much better approach than doing things manually and doing things in a brute force manner? So make sure whenever you have such kind of problem or such kind of situation where you are removing an array or array elements in place or string or characters, make sure to definitely try out about stack data structure. That will help you a lot in such kind of problems. So what we have to do, we just have to make sure that simply iterate over the arrays and make sure if the current element of the stack is equal to our current element of the nums. If it is, then simply remove and put their summation, and we repeat this number of operation, or we repeat this operation until we do not have the equal element, right? So this is quite easy. You just have to think about the state and think about the data structure, that will actually help you to come up with some approaches, right? And it is a standard problem, right? It's a standard approach, not a problem, I guess, because you have to, like, you got to use this in a lot of more different problems, right? So let's see the code is quite simple, nothing too fancy. I just have taken a stack data structure because that is going to help me to check if the elements are equal. I am just storing it inside the sum so that I can check for the multiple, because previously when I was solving this problem, I thought we just have one equal operation, like we just have to deal with the upcoming values, not with the previous value, right? So that's why I'm storing it inside the sum. If I'm just checking if the stack top element is equal to my sum. If it is, then I'm removing that element and updating a sum to 2, because we are now the summation of two elements, and I'm just repeating this number of operation until we got what we are looking for, right? And after that, if it is not the case, then simply inserting that element, and after that I'm just picking an element from the stack and storing inside my result and running it, right? So this is the thing. Let's try run a test case for better understanding. So let's take the first one, right? So this is my array condition, and right now what my sum contain, my sum instead of writing over here is, it is better to write this side for better understanding. In the first place, my sum contained 3, right? And my stack is empty, right? Stack doesn't have any element, so this part is not going to execute. Then we just simply put in sum inside our stack. So now stack contains 3, right? After that we move to 1. Now our sum updated to 1, and in this case this we check because stack is not empty, but we check if stack.peak is equal to sum. See, 3 and 1 are not equal. That means this part is not going to execute. Then we again put element inside our stack. Now stack contains this. This is our current stack state, right? Now we move to second one. Now our sum contains 1 again. Now we check while stack is not empty and stack.peak is equal to sum. If you see sum and the stack peak is equal, then what we do, this part is going to execute. Then we simply remove the last element. Then our stack is look like this. Do the summation. Now sum contained the value of sum is now 2. And then simply check. Instead of putting directly into it, we check for the leftmost elements, right? If you see the question, you see there is they have already mentioned that choose the leftmost such adjacent pair in the current array and replace them with a single element. What if the sum which I have made it, let's say this become 3, then instead of just putting back, we just check if it still satisfy the condition of this particular piece of code. That will actually help you as to solve this particular much matter, right? So now sum is become 2. Now we do the same. If it is satisfy the condition, not. Why? Because stack is not empty, but stack.peak is 3 and sum is 2, so they both are not equal. Then we simply insert the element sum inside the stack. Now our sum contain 2. If you see, the stack.top and the sum both are equal, which means we just simply pop out the element and my sum now become 4, right? After that we again check it's not empty and stack.peak is equal to sum. Now stack.top is 3 and my sum is 4, which are not equal. Then we are just break out from this loop and then simply put the summation of inside the stack. So this is the state of my stack look like, and if you see, this is the answer what we have to achieve. So this is the simple approach. Let's run the code for better understanding. You see everything is working fine. So this is the piece of code, and this is quite easy, nothing too complicated if you know how to deal with stack data structure. And make sure whenever you are solving such kind of statement arise, so make sure to use stack data structure. That will help you a lot and even more difficult problem as well. So this is it about this problem. Talking about the time complexity, which is of O of n. Why? Because they're just running off and loop over here and O of, and you can say in worst case. So this is O of n. Talking about the space complexity, which is also O of n, because you are taking a stack data structure. So this is it about this particular problem. Let's move to the third problem, which is more interesting. So this is the third problem, which is more easier than which is more easy if you actually know how to deal with sliding window approaches, and if you have if you have solved some sort of sliding window problem. If you are not able to solve it, don't worry, I'm here to help you. So let's see. Count subarray with cost less than or equal to k, right? So you are given an integer array nums and an integer k for any subarray defined as a cost. Maximum of the subarray and the minimum of subarray multiply the length of the subarray. Okay, return the integer denoting the number of subarray whose cost is less than or equal to k. This is a standard template which we can use over here. So let's first understand the problem. So what the problem is saying is that we have a integer array. So this is our array, right? And what we have to do, let's say nums of L to R is a subarray, is a part of our answer if the maximum of nums of L to R minus minimum of nums to R L to R multiply length of the subarray. Got it? So this is the problem. This is the main condition which we need to take care of. For example, if my subarray is this, right? So what they are saying that the maximum of the subarray, which means 3, minus the minimum of the subarray is 1, and we just have to multiply both of them with the length of this subarray, which is 2, right? And if you calculate this, so it's 2 multiplied 2, which is 4. If it is less than or equal to k, then this is this is the part of our answer, right? So this is what we have to achieve. So this is a pretty good question. If you haven't worked upon sliding window, then it might become a little difficult, not that much. So let's first understand how to actually approach this particular problem and how to like deal with such problems in future, right? So if you see, we have to what the problem is saying that return on subarray, which means we have to somehow find out the subarrays that will satisfy this particular case, right? So, and make sure, like, there is one more thing is that we cannot create any particular window over here, right? This is not a fixed size window problem which you can solve. This is not that problem, this is something different, right? So two things which we need to take care of if we are considering any subarray, then we should know the max element and max and the min element of that subarray. That is the key part of this particular problem, right? Because that is going to actually help us to solve this particular problem. But how do we actually take care of this particular thing, right? Let's say in this case I'm just running over the array, right? I have iterate over the array. My minimum element become 1 and my maximum element become 3, right? Then I move to, but let's say values case, the value of k is 2, not 4, right? And when I just calculating their answer, then answer become 4, right? Which is not less than or equal to k, which means it is not a valid answer. So in that case we need to shrink our window, right? Because it is not a fixed size window, it's a variable size window. So we have created a particular window, now we have to shift it. Let's say remove I move the I pointer to from 0 to 1, then my subarray become only 3, which means my maximum element become 1, become 3, and my minimum element is also become 3, right? But you see, I don't have any ways to actually think how can I just like check if it's a maximum, like when do I have to update my minimum and maximum element. So it is not that much possible to actually come up with. So instead of doing this, can we use some data structure? We can, because there is a standard way to do this. Why we can use dqs over here, like q over here. Why we are using dq? Because in dq we can perform operation from both the side, right? So that will help us to come up with. So in order to solve this, what we can do, we created two dqs. First is max, and let's say second is min. I'm just taking it as an array, you can understand it, we are just actually dealing with the queues. And let's take an good example. You can say, okay, let's take this one, right? So let's say this is the array elements. So now how to actually store minimum and a maximum element in a much efficient manner? Simply iterate over the array, right? And my max, like there is a two constraint which we need to take care of. Max will contain max elements at the top front, at the front, and min will contain min element at the front. This is the main condition which we need to take care of, which means if I want to pick the maximum element, I just simply go to the max queue and simply pick the first element. And same, if I want a minimum element, then I go to the minimum and just pick the first element, right? So make sure our queue should satisfy this particular condition, right? So just simply iterate. Let's say my current element is 1, right? So 1 is there. I just simply check if there is any element. For example, if the max contain let's say 0, right? So my current element is 1. So what I told you that my max should contain maximum element in their front, which means my current element inside the max is not satisfying my condition. So what I will do, I just remove the element from the max, right? And I do this operation until there is more element. For example, let's say this is the condition, this is the situation of my max, right? So I will remove all the elements which are there, and after that I just simply insert my current element. And same case with the minimum as well. I check if there is a max element, maybe like if the element is 4 but my current element is 1 which is less than 4. So I will remove all the element which are inside the minimum queue and I insert 1 in that queue as well, right? After that I just go to 3. You see 3 is greater than 1, which means it is not satisfying our condition. So we simply remove 1 from our max queue and put 3 inside it. What about min? We are not going to remove min, we just simply add it to the back of the answer, because maybe that is going to be the minimum element after some point of time. After that we have 2. You see 2 is not greater than 3, so we simply add, because it is going to be a max in future. And same case, but here it is the case that 2 is less than 3, which means we are removing 3 and we are inserting 2. So this is the state of our queues look like. So this which we have to maintain. And if I want, if I ask you to provide the max, then you simply go to the max and provide the first element, and same you go to the minimum, provide the first element, and you see this is actually the correct answer which we are looking for. So we are just going to use this, and at every point we just simply check if the operation of this is actually less than equal to k. If it is, then it is going to be a part of answer. If it is not, then we simply shrink by just removing by just moving our pointers, and make sure we have 2 pointer. I is to iterating over the array and j is to make sure the window, right? So this is 2 pointer which we are going to use. Let's see the code for better understanding, right, which will gives you the good idea about the problem. So I have taken a 2 dq, one is the max and the min, and make sure I'm storing indices inside it, because I'm going to shrink my window, right? So one variable is result, that will going to store my result. Then another window, like another pointer is j to form a window, right? Now what I'm doing, I'm just iterating over the array, and this is the case which I'm doing it to maintain my max should contain maximum element. So I'm just checking if max is not empty, and the front and the last of the max element should not be less than or equal to my current element. If it is, I'm just simply removing the last element until the element is greater than is greater than my current element. And after that I'm just inserting my ith pointer, because we are just storing the indices, right? That will actually help us to shrink our window, and same case for the minimum as well. And this is the core part of this problem. We're just checking the same operation, that if minimum and the maximum of the array and length of the array is greater than, which means this is a invalid window. So in case of invalid window, we are just simply removing those cases, such that we rest of the window are going to be our answer, right? So I'm just shrinking a window by simply incrementing the j++, and I'm just checking if my top element is less than j, then simply remove that element, because we have shrink the window. And same case with the minimum as well, then we are going to shrink the window as well. If this is not the case, which means our current window is valid, then we simply calculating the number of subarrays, right? And after that just returning the number of subarray which we found. So this is the code of the third problem. It is quite easy, not that much difficult. It's a standard one of the problem, right? And if you got confused, then go to the discussion section. You got to know about what problem you should solve. It will help you a lot in solving such problems. If you are not able to solve, then instead of directly going towards the solution, let's move to a discussion and move to hints that will actually help you a lot. Talking about the time complexity, so which is O of n, because we are just running off one loop. And talking about this place complexity, which is also O of n. So this is the third problem of the today LeetCode Weekly Contest, and this is it about all the problem. Fourth one is also quite easy, but if you want, I will make a video of that. Then do let me know in the comment section. I will love to make the video of the fourth one as well. And this is it for the video, and I hope you understand the solutions and understand the approaches and the intuition behind the problems. If you understand each part of this video, then do let me know in the comment section. Do subscribe to the channel, do like the video so that I got to know about and so that I got more motivation of making such more videos. And do let me know the comment about my explanation so that I can improve. And this is it for the video. Bye bye, take care.